Hello Water Managers, I'm Fauwaz Hanbali with the Water Management Systems Division at the Hydrologic Engineering Center. I'm going to cover the HEC-MetVue overview presentation. In this part of the presentation, we'll talk to you about how HEC-MetVue is used in SWMS. The core water management system, SWMS, is a real-time decision support system that integrates data and modeling tools. HEC-MetVue serves SWMS on both sides. On the data side, HEC-MetVue is primarily used for automated data processing, like translating source data formats, such as GRIB and NetCDF, to the HEC-DSS format, and transforming time intervals, 6-hourly forecast data to hourly, for example. Other automated HEC-MetVue applications include filling in missing values, time shifting of historic data, especially for extreme events or analog years, to use as hypothetical scenarios. And HEC-MetVue is also used for automated generation of reports on current and forecast weather conditions. On the modeling side, HEC-MetVue is at the head of the modeling sequence in HEC-RTS, which is the real-time simulation software package for SWMS that integrates HEC modeling programs and real-time data. Within HEC-RTS, HEC-MetVue combines observed and forecast graded meteorological datasets to serve as inputs for HEC-HMS hydrologic models and HEC-RAS hydraulic models. Typically, precipitation is the primary input from MetVue to HMS rainfall runoff models, but temperature data is also frequently passed from MetVue to HMS for evapotranspiration estimations. Then for HMS snowmelt models, MetVue supplies precipitation, temperature, and snow datasets. For HEC-RAS, HEC-MetVue can provide precipitation and wind datasets, especially for 2D hydraulics models. MetVue can also provide temperature datasets for RAS water quality models. And when HEC-ResSim water quality comes online in the near future for reservoir system simulations and SWMS, HEC-MetVue can serve up the necessary meteorological data, temperature in particular. Essentially, HEC-MetVue can produce gridded and non-gridded time series datasets, or both, to feed meteorological data into other programs in the SWMS HEC-RTS modeling sequence. Finally, HEC-MetVue provides additional value in SWMS through visualization and interactive operations and analysis. Basin average storm totals and meteorological data statistics in general can be visualized on the fly. Multiple map windows can be also tiled together for comparing different products, especially different forecast products. MetVue can be used interactively to modify gridded data as part of quality control or to generate what-if scenarios. Plus, animation is very valuable for viewing weather patterns and for gleaning insights into the possible effects on areas of interest. In the next set of slides, I will walk you through what an RTS-MetVue model alternative is and how to interact with it. First, let's talk about how to set up an RTS-MetVue alternative. Essentially, any session created in HEC-MetVue can be imported as an RTS model alternative for MetVue. With a MetVue session, you group together the various map window inputs for observed and forecast datasets. For instance, a session or model alternative that is intended for snowmelt modeling would include 4 input map windows, 2 map windows for observed precipitation and temperature, and 2 map windows for forecast precipitation and temperature. Once imported into HEC-RTS, the MetVue model alternative can be configured to combine observed and forecast datasets with a consistent time interval. Multiple MetVue sessions can be imported as RTS model alternatives. Each RTS-MetVue alternative needs to be assigned a key, either a number or a letter, to distinguish between the output datasets from each alternative. For example, a MetVue model alternative intended to use a quantitative precipitation forecast, QPF, can be assigned a model alternative key of Q. On the other hand, another MetVue model alternative not intended to use a QPF would be assigned a different key, such as a 0 or an N for no QPF. When we look at the RTS-MetVue model alternative editor in a bit, you will see how the settings are done to identify an output dataset that combines observed and forecast inputs. And MetVue will automatically generate and compute output map windows to display the combined observation and forecast, like the precip and air temp output map windows with the alternative key of Q, shown in the example image on the left. Just to summarize here, the first step of integrating a MetVue model alternative in HEC-RTS is to create a session in HEC-MetVue that would represent a model alternative in HEC-RTS. And for the HEC-MetVue session, create map windows and assign each to a particular observed or forecast dataset. Another important part of the RTS-MetVue setup is temporal disaggregation of forecast precipitation. This is done in the main HEC-MetVue interface by selecting the map window associated with the forecast precipitation and launching the temporal transformation editor. Typically, forecast precipitation has a 6-hourly time interval, and the HEC-MetVue transformation editor can be used to apply disaggregation patterns to produce an hourly dataset. The default disaggregation pattern is a uniform distribution with equal weights for every step in a disaggregation block. But quite a few other distribution patterns can be selected, like the middle weighted pattern you see here, which can better simulate intensities within disaggregation blocks. Again, keep in mind, if the disaggregation pattern is not explicitly selected, a uniform distribution pattern will be used during MetVue model alternative computations. So in a sense, this setup step is optional, yet it would be better to use a weighted pattern to introduce some measure of intensities in the disaggregated dataset. After creating a MetVue session with designated map windows for each input variable, the RTS-MetVue alternative editor can be used to identify the input information and output settings. The Input Settings tab will list the available map windows, which can be assigned to be used in either the lookback or forecast periods. The Input Settings tab will also recognize any basin average maps associated with the session, but make sure to include the shapefile under the MetVue subdirectory of the RTS watershed. Then for each map window row in the Input Settings tab, the input record path name would be defined to match what's expected to be available from the HEC-RTS data extract. Finally, the Output Settings tab in the RTS-MetVue alternative editor is where output datasets are defined. For example, a precipitation output dataset can be added here to combine an observed, interpolated dataset with a forecast dataset, such as the forecast precipitation product from the National Digital Forecast Database, NDFD. If an output temperature dataset is needed, it can also be added to the list of output datasets. Then for each output dataset, there are important settings to match what is required by the model that MetVue is feeding, typically HMS. Required output settings would include the time interval, parameter type, and record path name. Another important setting is the output extents. From the drop-down list, select a shapefile that is part of your MetVue project, and most importantly, a shapefile that at minimum covers the entire extent of your basin model or a reasonable buffer beyond your basin model. One other thing to note here is the MetVue model alternative setting to automatically generate basin average time series. With this setting, MetVue can provide time series data to another model that needs it. This can also serve as supplementary output for data analysis or generating statistical summary reports. Let's talk about the RTS model alternative simulation. The MetVue model alternative will list the various input map window nodes in the forecast run tree. Each map window node has color-coded lightning bolt icons to indicate the state of its data, especially whether or not the data successfully loaded. Solid red if the dataset failed to load, solid green if successfully loaded. As soon as the HEC-RTS forecast simulations data extracts are done, if there are gaps in MetVue's input data or if the data required any transformation, like changing the time interval, MetVue will automatically process the data to fill in missing periods and apply temporal transformations. For those situations when data filling and temporal transformations happen, the map window node would have a hatch green lightning bolt. Clicking on the map window nodes in the forecast run tree provides shortcuts to several MetVue actions without having to launch MetVue's main interface. With the MetVue Actions shortcuts, you can apply measurement value adjustments, like applying a factor, or you can move or rotate a grid set to generate a hypothetical scenario. When the data is edited, the map window node will get a gray lightning bolt. Then, once the RTS-MetVue model alternative is computed, the MetVue output data sets are automatically passed on to the other linked models. Also, clicking on any particular map window node in the forecast run tree will display the base and average layer and its legend directly in the HEC-RTS map window. The HEC-MetVue base and average maps overlay the model elements from other model alternatives like HMS, ResSim, and RAS, so you can easily and quickly jump between the input, observed, and forecast map windows to get a good sense of the data distribution over your basin area, control points, and projects. But as you see here, there can be several combinations of observed and forecast data sets. Observed precipitation products can be available from various National Weather Service sources like the Real-Time Mesoscale Analysis product RTMA and Multi-Radar Multi-Sensor MRMS product. And a QPF product out of a river forecast center is yet another option too for observed precipitation. Then if radar products aren't reliable for a particular area, interpolated grids from observed station measurements can be used. There's an assortment of forecast products too, like the high resolution rapid refresh HER product with about a 2-day horizon, and other national forecast products with different horizons varying from 3 days to 7 days, even 16 days. So pick the combination of observed and forecast products that are most reliable for your area and fit the forecast horizons that you are after. In summary, HEC-MetVue is a versatile program for visual analysis and processing of gridded meteorological data. MetVue has a lot of interactive tools, including animation and data processing and editing tools for trimming spatial extents, applying spatial and temporal translation, and applying measurement value adjustments. Finally, many of MetVue's operations can be automated through its batch process utilities, and MetVue is also used in SWMS to assess weather and watershed conditions, as well as compute and generate forecast modeling scenarios. This is the end of the HEC-MetVue overview presentation. If you have any questions about our software, need some help, or looking for additional training, please check out the links below, and thank you for your time.